the hydrogen is offering a new way to transport energy and also to store energy and also to buffer energy. A more stable hydrogen production on a larger scale. We will also see other markets follow this and to base their energy input on hydrogen.
This is EnergyCast, and I'm Jay Downhauer. Today we are talking about renewable storage using hydrogen instead of batteries. Back in episode 66, my guest suggested that hydrogen is a perfect way to store excess renewable energy. Plus, it is much more value as a fuel in its own right. Renewables are intermittent. They often run as the weather dictates. As more renewables join the grid, we get to the point where they are producing too much energy. It's bad for everyone. The price of power plummets, conventional power sources have to either shut down or idle, and it's generally disruptive to the system. Storage serves a useful purpose in that it can suck up all this excess energy and use it during peak demand. There's a huge financial incentive to delay this energy, as my compressed air energy storage guest explained in episode 57. What if we didn't need expensive lithium-ion batteries or even pumped storage? What if all we needed was a body of water and some storage tanks? The excess electricity could split water into hydrogen, and the hydrogen could be saved until later. This week saw the end of the Watchmen series on HBO. I'd been a fan of the comic and the movie that came before. Now there's a superhero in that series named Dr. Manhattan, the smartest and most powerful of them all. And I was reminded of the line in the original story about Dr. Manhattan's choice of a logo for his costume.
The marketing boys say I need a logo,
which is a simple representation of a hydrogen atom on his forehead.
If I'm to have a symbol, it shall be one I respect.
Yep, one proton, one electron. So simple, and as our guest today would agree, so effective. With hydrogen, you could power electric vehicles with easy-to-refuel power cells. You could also combust hydrogen in a turbine. You may have seen some pictures from my recent talk at PowerGen last November in New Orleans. I was approached by a very large corporation that is moving very quickly to adapt their power production equipment for that very purpose. After speaking with today's guest, I am more and more convinced that the sea and oceans hold an important role in our energy future. Splitting hydrogen is just one example. You'll remember my fusion guess, how important isotopes of hydrogen are for power production. You'll also remember my guest from episode 54 who had a method for pulling CO2 out of the ocean, also to potentially produce energy. We may one day look at our oceans as one large battery to power our sustainable energy needs. My guest today is Klaus Oltmann, Business Development Director for Tractebel Overdick, an international engineering firm based in Germany. The Tractebel team is developing an offshore hydrogen production platform that could run entirely on offshore wind power. I found out about this technology on Instagram of all places, with an image of a brightly colored oil rig surrounded by wind turbines. Klaus and I discussed the many different configurations this setup could take, as well as many variations of renewable energy that could support it. I hope you enjoy my conversation with Klaus Oltmann. We're here with Klaus Oltmann, Business Development Director at Tractebel Overdick. Klaus, the first question, the components of this process, wind energy, electrolysis, are all established technologies. Are you developing any new intellectual property from this process?
Basically, we are not developing any new or completely new intellectual property. We scale the existing technology to the next level, and we bring this to an offshore environment and using well-known technologies out of the oil and gas business, out of the offshore wind business, and combine this now with the electrolysis technology.
How much more have we scaled up?
Currently in Germany, the biggest project is a plant with 100 megawatts. We are considering 400, so there's a factor of 4. That's kind of scale of size you need in order to make it economically viable offshore.
What gave your team the idea to pursue this approach? Was there a client who needed hydrogen?
Yeah, seeing the development of the market, we have been observing that there's a certain issue with power transmission from offshore offshore wind farms to the onshore electrical grid. And we see hydrogen is coming up as a solution to overcome certain transmission and also energy storage and buffering issues. And that brought us to the conclusion to develop this type of platform.
The wind is offshore. The hydrogen conversion equipment appears to also be offshore, what would look to many people here in the United States like an offshore oil rig. Why wouldn't all the hydrogen conversion equipment be located on the shore? It seems like the electricity could complete the hydrolysis. It could be wired to the shore and then they could do the hydrogen conversion there.
That's one of the questions which, of course, came to our mind and we raised that. There's a simple answer to that. The electricity costs offshore are much more cheaper if we talk about offshore wind. We bring the hydrogen production offshore because we have cheap green energy offshore, which we do not have to bring onshore and generate costs by bringing it onshore in order to produce the hydrogen. We claim that there will be an increased demand of hydrogen onshore, but on the other side, the electricity costs offshore are lower for the green energy compared to the onshore environment. And that's how we came up with the conclusion bringing the production of the hydrogen offshore might be a better solution for production of green hydrogen.
You're talking about doing all this process offshore as opposed to maybe running long transmission lines from the wind farms. Is that what you're talking about? You don't have to run the transmission lines back to shore? That's the savings?
Basically, yes. On the other side, the further you go offshore, the more complicated the electrical transmission is. For the long distances, you may need to the high voltage transmission, which is requiring quite a lot of infrastructure offshore to create the direct current out of the AC and then to convert it back into AC onshore. Quite big facilities required, and these facilities are driving the transmission costs. So if you could save this and go directly into hydrogen offshore, that reduces the levelized cost of hydrogen production.
Here in the United States, we have state-controlled waters, we have federal waters, and it's international waters. Have you thought any about what waters you wanted to be in? I assume federal waters. Would any of that help influence where this kind of facility would need to be positioned in the sea?
Well, that's quite an interesting question because in order to make the hydrogen production offshore viable, you need to look into a case-by-case option. The question is, if you produce your power offshore, where would you land it onshore? Mm-hmm. Would it be in the same state? Would it be in a different state? Is there a energy demand directly onshore if you consider the shortest connection? Or is there another solution where you just transport the energy over a very long distance to another state, also to an area where you have a very high energy demand? And these options are to be considered. The hydrogen is offering a new way to transport energy and also to store energy within the pipeline or within some other solution, and also to buffer energy. It is much more flexible, and especially if you look into the transmission grid onshore in the United States, where you get problems if you have to cross the border between one state and the other. Maybe hydrogen could become an option to overcome certain issues also in the United States.
I used to spend a lot of time here in the United States, the fracking industry, doing a lot of water recycling. So I know a little bit about water treatment, but I don't know very much about converting seawater to hydrogen, which I assume how the hydrogen would be produced. So is it more difficult when converting seawater to hydrogen than, say, fresh water? What are some challenges there?
It depends a bit on what kind of technology you use. We consider membrane technology, and we would require fresh water and clean water to do so. So we would have a desalination plant, a filtering plant, and a water treatment plant on board of the platform. But this is also well-known technology, and we do not invent anything new here.
Membrane, like a reverse osmosis?
Comparable to that, it's a proton membrane where we split the water into the hydrogen ions and the oxygen part.
Okay. I interviewed a guest who's developed in the United States a hydrogen fuel cell infrastructure for large companies for fleet vehicles. This can be large trucks. It can also be a lot of forklifts. You mentioned this earlier, Klaus. He also said it was smart to make hydrogen as a storage medium from renewable energy. So I assume you believe this is also the key to the hydrogen economy. Think of hydrogen as a storage medium for renewables.
Yeah, I can fully confirm this. On a long-term basis, hydrogen might become a leading player in the energy market. Also, as you said, for the field vehicles, for the trucks, hydrogen will become a serious player in that market. And I personally think that all the battery and electric car solutions are midterm solutions, but on a long-term basis, we need to consider hydrogen as a very serious story.
Is there a carbon credit for producing hydrogen from seawater that could help your economics?
Well, that's a tricky.
Depends where you are.
Yeah, we haven't considered that in our studies so far. The reason why we choose the seawater is because offshore wind power is becoming cheaper and the wind farms are becoming bigger. But we have still to overcome the issue that the wind is not on a constant level. We can, on the one side, create a transmission grid infrastructure to overcome that and design the infrastructure for peak loads. But on the other side, it's much more easier to design everything for buffering the peaks and to store the energy up to a certain amount and to equalize the power transmission to an optimized economical level. That's the main driver on our ideas, and the carbon credit was not playing a major role in our thoughts up to now.
That brings up a good question, this idea of if the wind isn't blowing, what then? And this is a different situation than if you were producing wind energy for the grid. You're just producing this to run essentially a hydrogen production factory. I would think that with the exception of the people who would be on the platform, are you planning on having constant hydrogen production even if the wind isn't blowing? Or is this, when it's not blowing, we won't?
Yeah, that's actually the idea. We can trigger the output and the required power in a very quick way. Even short-term fluctuations in the power input of the platform due to the wind is not causing any big troubles from the production point of view. The idea is to harvest all the wind we can get, and we don't care about peaks, we don't care about low winds. We just take the energy what we get, produce hydrogen, and either we store it somewhere offshore in caverns or bring it onshore and supply this to the industry or to the market, but that we just follow the wind profile and produce in accordance to what kind of power is supplied.
What's powering the platform if the wind was completely still?
We will have a buffer storage of hydrogen on the platform, and then you can, of course, use the hydrogen to power the platform. That's the optimum case. On the other side, we can think about battery storages. We can also think about diesel generators, but of course, if we talk about a green solution, diesel is, of course, not playing a major role.
Certainly. I'm curious, electrolysis is a very old technology. Renewables have been around for a while. Why do you think it's taken so long for making hydrogen from renewables to capture the imagination? I'm just now hearing this idea of using hydrogen as an intermediate for storage for renewables.
Yeah, hydrogen electrolyte, that's a very, very old story. That's true. I think that the capacity of the electrolysis plant, we've had a quite good development throughout the last years. And of course, the pressure to look into alternative fuels, not into diesel, gasoline, and these things, that there is a certain pressure on the market to go for new solutions and also to invest more money in R&D works in these new solutions. Hydrogen is becoming a more and more important fuel, also with regard to the properties of that type of fuel. You can store it like a gas, so the handling is well known. You can even in combustion engines. It's a very flexible type of fuel. It's also suitable for a mass market and big production. And we've seen as well now in the vehicle and in the automotive industry, the batteries are leading to a more economic development and a higher efficiency. But on the other side, we see as well the environmental impact of producing these batteries, which is coming up more and more to the awareness of the drivers of these types of cars. Hydrogen is also overcoming this, and of course hydrogen is not as far as developed as we would like to see it. There are still certain issues on efficiency, on safety is of course another topic. Hydrogen is quite a reaction-friendly gas, but hydrogen is suitable for larger scale projects, and that makes hydrogen so interesting for the offshore business, as the transmission and the pipeline technologies are well known, the gas facilities are well known to the industry, and now we have a medium which can be used to store the high amount of energy which are produced offshore nowadays.
Drilling down on that a little bit, was there anything up to recently that kept hydrogen from being considered seriously as a intermediate? Were people concerned about transportation, the storage? Was there alternatives out there that were better? Why do you think hydrogen is just now being considered when all of these other technologies technologies were in place to do this many years before now?
Good question. I don't really have an answer. I think it is all about the development on the capacity side. The latest sizes of hydrogen production plants are now coming into regions where these capacities are becoming interesting for the big offshore wind market. At the moment, we talk about offshore wind farms to be developed in the size of 1 or 2 gigawatts per wind farm. And to store that type of energy, even for equalizing the energy production peaks, you will not be able to use the batteries for that. There were some ideas to use compressed air, but hydrogen is becoming more and more the idea to use it, because the production of hydrogen, that's fairly easy. All you need is a bit of power and some membranes, and you produce hydrogen. The efficiency, okay, but if you get the energy more or less for free offshore, it's becoming a good alternative. Also, that's maybe a bit sidetrack here in Europe, there is an issue with the energy transmission. For instance, in Germany, on a windy day in September, we have a problem that the energy produced offshore is more or less wasted because there is no good transmission link between the offshore site and areas where this energy is required in the south of Germany. You're actually paying money to the market, that the market is buying your energy. Yeah, not a case which is economically viable. Hydrogen kicks in because you can store the energy, and you can also buffer the energy within a pipeline, within the gas network, and it allows you to pay money during peak times and get money for your energy in times where you don't have these peaks. There is no other medium which might be in a position to address this very large-scale topic, and I think that's one of the reasons why hydrogen is becoming that popular at the moment.
You mentioned a lot of uses for hydrogen, but what do you believe most of the hydrogen will be used for? I could see it going for automotive. I could also see it going for power production, like we're talking about here, a storage medium as an intermediate for utility scale electricity.
All a bit on the infrastructure you have where you land on your hydrogen, but a lot of heavy industry is requiring hydrogen for production. Power production is of course quite easy with hydrogen, and you could also feed the hydrogen up to a certain amount into the natural gas network, for instance. It's a bit a chicken and egg issue. There won't be bigger infrastructure if the big hydrogen supply. So the question is what comes in first. And I think that now with the offshore wind farms, we will see an increase in hydrogen production. And this is, of course, leading to a higher demand on hydrogen on a later stage. But hydrogen is very versatile with regard to of the usage. We will see, for instance, a lot of buses in the cities are running on hydrogen nowadays. And there's a high demand in areas with high population, but also using hydrogen as a buffer and to produce energy out of the hydrogen in very high demand times where you don't have the wind blowing. That's an alternative. Once we have a more stable hydrogen production on a larger scale, we will also see other markets to follow this and to base their basic energy input on hydrogen.
The technology that we're discussing today is essentially wind to hydrogen, but are you pursuing other renewable to hydrogen projects? Solar, hydroelectric also comes to mind. The water's already there. Any other possible ways to expand upon this technology beyond wind?
Yes, of course. We're looking into that. Solar is a very good example because you're already producing direct current, so you can directly produce the hydrogen. It's also about the scale of size. So we look not only into the big hydrogen plants, we look also in smaller hydrogen plants. For instance, if you have islands in a very remote location, you can think of decentralized hydrogen production to these islands with a very low hydrogen consumption compared to continental Europe or United States. There's quite a big market opportunity at the moment, and we're of course looking into all different kind of options.
Klaus, going to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
It's state-of-the-art technology and fuel. We may see this a bit further increasing, but it's also using the basic technology which could be used for hydrogen as well.
Crude oil.
If we talk about vehicles, and especially ships, we will see that the crude oil is becoming on a long-term basis less important, and the market is requiring alternatives.
Nuclear.
Still on the agenda and will be on the agenda for the next decade, but there's still a question on what to do with the nuclear waste after we use that technology.
Coal.
It's certainly on the decline. Yeah, coal has no future, in my opinion.
Wind.
A very good technology, especially offshore wind. The question is if we are able to unlock the potential of floating offshore wind, then offshore wind is becoming quite a big driver for the energy market.
Solar.
Cheap and good technology. And of course, as I am out of the offshore world, we are of course now looking into solar plants offshore and inshore. Solar still has a very good future potential.
Biofuels.
Yeah, difficult to judge. Will be on the agenda for the next year, that's for sure. We'll have a certain market segment to it.
Hydroelectric.
Still a very good technology, a green technology, depending on the countries and the size they can economically use that technology.
Geothermal.
I think that goes hand in hand with the hydroelectric. There are spots in the world where this absolutely makes sense and will provide you with a quite cheap energy source.
Energy storage, essentially your technology.
It's becoming more and more important if we are talking on a diversification of the different energy sources.
Electric vehicles.
Might not be the long-term solution. I think that the hydrogen will become a good alternative to that.
Good point. Energy efficiency.
Yeah, that's, if you ask the engineer, should be the driver of all kind of technology to be efficient. And energy efficiency is, of course, to be addressed, especially for the new technology, to make these technologies more and more efficient.
And then finally, fusion power.
It's a long track. I'm interested in that type of technology, but we need a breakthrough in order to replace all the other technologies with the fusion power. I think that's still a long way to go and a lot of research to be done. But in the meantime, we need other technologies which are green and which are replacing old-fashioned oil and coal energy sources.
All right, Klaus Oltmann, thank you so much for your time.
Thanks for giving me the opportunity to address this quite important topic.
That was Klaus Oltmann, Business Development Director for Tractebel Overdick, an engineering firm based in Germany. The platform under consideration could produce as much as 400 megawatts of energy for hydrogen production. I want to thank Klaus for his time, as well as Felix Nicker at Tractebel for setting this up. You can find plenty of pictures on energy-cast.com, as well as on Instagram at Host Energy. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 73. Be sure to join us next week when we speak to a carbon capture startup that got some welcome attention during the college football season this year. Until then, I'm Jay Downhauer. We'll see you next time.